Hello, good evening. Hello, good evening. My name is Abhishek Kumar Sai, and now I am going to present my final project on speech emotion recognition by using BILSTM and self-attention. This project is a web-based that predict human emotion from audio speech. In simple word, user upload a raw file audio, and the system listen to the voice pattern, and then it predict likely to the emotion. The main idea is that possible do not express feeling only through the words. This also express feeling like tone, audio, species, and poses, and when and voice standards. Now we'll move to the slide number 2, presentation roadmap. In presentation roadmap, there are divided into four type: research context, research analysis, product demo, and conclusion. In part A research section, tools used for data preparation, modeling, and analysis and evaluation. Now we'll move to the research context. Why this project is needed? This project is needed this project is needed. Human emotion is one often shown through one tone, pitch, poses, and intensity. Computer normally poses word, not emotion. Speech emotion recognition can support visual assistant, customer service, online learning, and healthcare, and voice assistant. Problem statement. The main problem are the main problem is that predicting emotion from speech is not easy. There are few reasons. First, different people express the same emotion in different ways. One angry person may speak loudly, and while another person may speak quietly but seriously. Second, audio quality can affect the result. Background noise, poor 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 microphone, and different recording devices and prediction harder. Third, a dataset may have same number of sample uh, for ev- for every emotion. This can affect will the model learn is emotion. Fourth, the model may be overfit. Overfitting means the model perform well on training but does not perform well on a new audio, on a new samples. A main objective. This project focus on classifying emotion from speech audio using a lightweight deep learning pipeline. Develop a web-based speech emotion recognition that takes speech audio as input and output the predicted emotion from the category. From objective one, like extract MFCC delta features from speech signal. Objective to use BILSTM to learn forward and backward speech context from both direction. Third one, apply self attention to focus on emotionally important frames. Evolution of speech emotion recognition technology. This is also a move from handcraft machine learning to deep learning model and attention model. From traditionally we use like SBM, GMM, and SMM with the manual feature. Then we'll move to deep learning. Deep learning use the CNN and RNN learn research speech pattern. RNN means recurrent neural network. This deep learning follows, and this deep learning follow on the BILSTM. Did past and future context. Then we move to the attention only focus on the important emotional frames. Now we'll move to the hybrid model means the CNN LSTM model attention for stronger result and transformer model. And this project focus on the MFCC and delta future with the stack by LSTM and self attention. Now we'll move to the resource gap and contribution. In resource gap continuation, gap on complexity. In this resource gap and contribution, exiting method can accurate but many heavy or complex for a student web product. Gap 1, complexity. It uses the CNN heavy graph based or multi-data set. Many multi-data set system can increase computation and implementation cost. Gap 2, practical use. A final product also needs simple upload and clear output and confidence score and history. Response, project contribution of practical pipeline like MFCC delta features, stack BILSTM, self-retention, and web development. Many system only focus on the model, but they are not always easy for the normal user. My project connect the trained model with a simple web application. User can upload audio and see the predicted emotion, view the confidence score, and save history in Firebase store. Now we will move to the data set data emotional speech. The data set provide label speech recording for training and testing SCR model, speech emotion recognition model. First one, label label. Each file has an emotional label which support the supervised learning. And second, emotional categories. Like in the emotional categories, in eight there are eight classes: neutral, calm, happy, sad, angry, fearful, disgust, and surprise. And we'll move to the control recording, useful for moral training and fair comparison during evolution. Daily life example: a calm voice and angry voice may use the same sentence, but tone and pace can be very different. And resource tools, getting and preparing data. These tools support data set, audio loading, cleaning, future and future prevision. RapDash data set for the training and data. Google Colab is used for the trained model, and Python 3 is used for the main programming language of this main programming language of this the project. And Librosa is used to load audio and extract MFCC features. And NumPy is used for the numerical, and Pandas is used for tabular data handling. And Skitlin learn data splitting matrices and pre-processing. And other part, TensorFlow and Keras build and train a BILSTM self-attention model. Callback is used for early stopping and reduce RL and play, R on plateau. Matplotlib and Excel is used for accuracy loss and result visualization. And Jupyter and Colab is used for model training. GitHub is used for version controlling, and PowerPoint is used for the presentation and code explanation. In methodology section, this uses this methodology use an agile style process because machine learning need repeated testing and tuning. Repeated testing and tuning. And requirement and system planning defining the expected dataset collection and pre-processing, convert raw audio into training data. Model construction and tuning improve performance step by step. Testing and deployment planning, check the final product workflow. Why agile? Why we choose the agile? The model require the repeated changes in its future padding. The model require the repeated changes in future padding, model depth, and learning rate before reaching the good performance. Reports the good performance. Data pre-processing pipeline. Data pre-processing converted raw audio into the clean, consistent model and input, model ready input. First one, load the audio, and it normalize and extract the MFCC and delta feature, and then remove the pad sequence and include level and training test data. First one, cleaning reduces distortion and support more stable training. Padding makes sequence length consistent for the model. Label including tone emotion came into the numerical classes. For future extraction means MFCC plus delta features. Audio must be converted into the numerical feature before cleaning the model learned from it. First one, MFCC means sound pattern. Capture tone and frequency information close to the human hearing. Delta, first change over the time means velocity. So how the voice change during the speech sample. Delta is second change over time. Use the double BILSTM. 8 for information about the movement in voice features. Combined features give the model both. Combined features give both the model static and dynamic speech information. Model architecture, BILSTM, and self-attention. This model read speech context and focus on the emotionally meaningful way. First one, input MFCC delta and delta feature sequences. Two BILSTM layer from learn forward and backward speech concept. Self attention highlight the important part of this. And global average pooling means and global average pooling and softmax produce the final emotion classes. Feature BILSTM and attention and emotion. How self-attention help? Self-attention make the model more selective and easier to explain. Full speech sequence, move to the attention weight, and attention weight with the important frame and better emotion prediction. Important word pauses. Important word pauses or tone change can carry stronger emotion. Attention help the model focus on this part instead of average everything equally. This can improve both recognition, performance, and interpretation. training strategy and control. This model use callback this model used to callback to reduce overfitting and improve stability, like dropout batch normalization, early stopping, and reduce iron plateau. Evaluation matrices are accuracy, precision, recall, and F1 score and confusion matrices. Model also in this it provide 94.44 percent accuracy, and test sample are 576, and this is high uses the double BILSTM layer. Risk management, like dataset path missing, broken audio file, overfitting, API upload issues, confidence score, privacy and security. Key source finding, MFCC with the delta feature provided a useful information about voice pattern and says over a BILSTM is suitable because emotion is expressed. Sequential attention focus on the emotional part of the speech, and the model performance is strong, but real world testing is still needed. Limitation, dataset limit, noisy weight, confidence score, privacy and fairness. Del life example, user can upload a call audio clip, and feature are extracted through the MFCC, and model predict emotion and staff can respond more carefully. uh, problem define resource section summary, problem design tools selected, model MFCC and result evaluated, and product. Now we will move to the part B, product type. Now we will move to the part B, product type. All main component, user side demonstration, developer side, and technical demonstration. This is a this is an product overview. Product overview is a web application for audio, for uploading speech and receiving emotion. User can upload audio file, and backend extract feature and run the train model, and the system display the predicted emotion and confidence score, and prediction can be save and review in the history. First of all, a user can register or login, upload and edit, predict emotion, history, save history, and review result. In front-end component, there is registration, login, audio upload page, prediction output, and login, prediction output, and save history. And this is an use case diagram and user interaction flow. The use case diagram explain about what the user can do in system. This is an backend. This is an backend and API pipeline. The backend connect the front end, upload to the trend model, trend emotion prediction model. Front end upload through the Flux API route, and feature extraction and model prediction. Model integration and prediction flow. Model integration and prediction flow uses the audio file upload, audio file move to the MFCC and delta feature move to the BILSTM and self model, and it will BILSTM and self model, and then it move to the dense layer, and then it will show the output, predicted output. And Firebase authentication and database it is used to save the user login and register, and user login register history, preview of predicted data. That was product demonstration is a technical slide. A slide show developer side evidence for the working code. This is the backend code, model output for accuracy, and Firebase data store. Test testing and product evaluation, all can be tested through the main user journey and system response and save history. Registration, login, audio upload pass, and emotion predicted storage save, and all are pass. Product section summary. Product section summary demonstrate that front-end provide login, upload a prediction result, and store. Backend API connect the user interface to the train model. Feature extraction prepare the speech audio in the correct input format. Firebase support authentication and predicted result in database. Testing confirm the product workflows. Conclusion and future. This project is usually successful link the research, deep learning, and web-based product development. Main achievement learning evidence. The main achievement is the system predict emotions from audio speech using MFCC feature, BILSTM, and self-attention, and learning outcome. This project improved the understanding of the audio processing, model training, API integration, and product testing. Overall, the system create a strong base for future development in effective computing and human interaction. references like this. And thank you. Now we'll move to the demo, but then we will to open terminal. First we want to connect a backend, then cd backend. Then it was already start on the development phase like this URL link. Now we want to connect the front end part also. Then we have to go live. Then first we want to create a new account. Then we click onto the register. First we have to take the any name like register. After creating a password, then you will to click on create account. Then it was already login to the main home page. Then we'll this is our home page. This is our home page. Then we want to extract a prediction. Then we want to upload a audio file. This is an audio sample file. Then we have to click and then we want to click on predict emotion. Then it will show the result emotion calm and confidence 99.98%. Then we want to click on back home. Then and we can also show the predicted save history like this, and we can also predict a new prediction also on this account. Browse, then another pick audio sample. Then again it will in that audio sample it will show sad confidence 99.84%. Then you can also show history. In first time it will show 99.98% calm, and second on another audio sample it will show 99.84%. Then it will go to back home. Then it was already saved on our history page. Now this already shows sad and calm, and we can also predict other audio sample also, but this is limited for this. And this is our about page like speech emotion recognition, and this is our complete completed completed for predicting human emotions. And then this is our complete this is our complete our project. Then we want to click on logout button. Again we want to again we want to create a new user for new predicted emotion, and it save our data in the Firebase data console. And this is our and now we'll move now I will move to the database part like Firebase. And this is our Firestore real-time database and authentication. In real-time database, first one we will test our user login like testing at rate gmail.com, and its user ID is the this, and we predicted our data in Firestore. It takes certain time for loading. And this is our shape prediction data. This is our existing. Now this is our tested data in the time sad and uh, audio data file. This is last data I will save our sad calm, and this is our tested predicted data on the database Firebase database store. And this is our completed project. Thank you.